Hello and welcome. We are continuing our PowerShell sessions, and today is the fourth session, and we are going to talk a little bit about security. Security in Windows PowerShell. Security is usually the first thing you encounter when you are trying to execute the PowerShell scripts on a freshly installed system after you install the Windows PowerShell. And usually, perhaps it's the most common query in Google regarding the PowerShell, how to run the script, how to change the execution policy of PowerShell. As you know, Microsoft tried to create PowerShell as a more secure system than the previous one, which was the Windows scripting host. You know, all this I love you worm that was sent as email attachments, the VBS files, the WSH files, which were running on demand. Microsoft created PowerShell as more powerful scripting system, more powerful scripting platform. So definitely they wanted to make it secure by default, so they did it. When you install Windows PowerShell, by default you cannot run simple PowerShell scripts unless they are signed and unless your computer trusts the signature, trusts the certificate behind it. So one of the first commands that people are running, I think statistically, is they are disabling the execution policy or make it enable to run any PowerShell scripts. However, on many corporate environments, this is not the case. This is not the allowed thing to do. So usually we are running set execution policy and there are few parameters that we can give to that command. One of them disables the execution policy, but we can also return it back to default. So let's try to run the PowerShell script. And by the way, take a look. I tried to type the script name, which is in this directory in labs. I pressed tab and it was automatically completed, but as you can see in the beginning of the name I have dot and slash. I will return to it later why it was auto-completed this way and not another. But now let's try to run the PowerShell script with default execution policy. The error we've got is the execution of scripts is disabled on this system. So that's what you get on a fresh system. So you cannot just run any rogue script or even any good script unless it's signed and you trust its signature. So there are two ways. You can either try to avoid having the execution policy, which is not secure way, or you obey this execution policy, which is much safer and is quite easy if you know what to do. So the meaning of this session is to show you how to obey, how to respect that execution policy. Also, we will talk about authentication later. So set execution policy to remote signed. As you can see, it's case insensitive. And now we can run this script. However, the remote signed is perhaps not the most secure setting. Actually, it's not secure at all, because you know this PS1 file is a custom file, so it could do whatever to your system, and well, So take a look. /current verb .ps1 run the script, but without it, it doesn't. So this is a security feature of Windows PowerShell. Why it was made so? Because if you remember in previous systems before the PowerShell, you could create your own programs or your own batch files which would have the same names as system commands or other programs, and when running from that directory they would overwrite all other programs or commands, shell commands, and would execute instead. So you could have your own explorer, exe or bot or whatever that would run for the command explorer when it's executed in that directory. This is not the case with PowerShell. With PowerShell you have to set this path that you are running this script from this directory, that you know what you are doing. In that case it will be executed, and the execution policy is irrelevant in this case. Even signed scripts will run only if you will set the path. And as you can see, yeah, it's here. But no, we cannot run it without the /. Now, when you're the system administrator, in a network, perhaps one of the things that you will want is to disable a running of unsafe PowerShell scripts, but also enable running of your scripts. In that case, you can do it through the group policy. In group policy, you can set the execution policy for PowerShell scripts, and I'll show you how to do that. First thing you need to get, and you see the link in the screen, it's the administrative templates for Windows PowerShell, which will enable, which will allow you to have that setting in group policy. I could run gpedit, but I'm not looking for easy ways, so I'm going through group policy management, go to our domain and edit the policy. Right click and edit. gpedit.msc would be a bit faster way to do that. So by default I don't have that setting here, so I will have to attach the template for group policy. I'm going to computer configuration, policies, administrative templates. Then right click it, add remove templates, add, and just browse to that newly installed template. That would be setting the group policy is like the same as running the command on each computer to which this policy would be applied. But it has also one feature, one quite important feature. Why would we use the group policy even in small networks? And you will see why. So as you can see in administrative templates in Windows components. We have Windows PowerShell now, and with only one setting of turn on script execution, which is not configured at the moment. And we can enable it, and when we are enabling it, we can specify the execution policy. So we are allowing local scripts and remote signed scripts. We don't care much about security. Now what we have to do is to update the group policy on this machine. We are doing it, as you know, with the gp update /force. We are doing it on the main controller, but still we need to update the group policy. Okay, here we go. Now, when we get the get execution policy, it's remote signed. It was remote signed before, but at this time it was taken from the group policy. So, the security feature. When you are trying to set execution policy now, for example, to all signed, you get the error, and the error says that, you know, the setting is overridden by the group policy applied to your system. So, if you have that setting through the group policy, even the local administrators will not be able to change it, and that's good, in case you want it. So, as you can see, the setting is overridden. So, in that case, if, well, usually in real life we set it to perhaps all signed. We just want that only our PowerShell scripts would run. And if some custom PowerShell scripts would run, would need it to be run, we would sign them first. But in this case, in our example, we just allowed everything, and we do not allow changing it back. Could be a real-world scenario as well. So now we are changing it back to not configured, which means that computers become independent and local system administrators are able to set that setting. Now, without the updating the group policy, as you can see, it didn't change. So you have to update the group policy. The group policy is automatically updated when you log in, or when you are logged on, you have to update it with gp update. It's automatically updated, depends from your settings, but if I remember right, usually it's about 90 minutes. So if as system administrator you change that setting, don't expect it to be applied immediately in your network. Okay, so it's updated. And now, as you can see, it's all signed, just as it was before the default one. Okay, so the make cert command is the program makecert.exe, which is part of Windows SDK and Windows Platform SDK and .NET SDK. So by default, you don't have it. You can download the free .NET SDK or Windows Platform SDK from download.microsoft.com. Get the current one, and well, you'll have it. It's quite important to have the latest one because of the never-ending security issues with which are related to SSL. We'll talk about it a little bit later. And with MakeCert, you are able to create your certificates that you will be able to use in various scenarios, including the signing of the PowerShell scripts. The second scenario is to use the local certificate authority, like when all of your computers belong to one domain, or at least all computers on which you will run your scripts trust your root certificate. I hope you know what is the root certificate. The root certificate is actually the root certificate. Is the certificate which is the beginning of all of your certificate authority, the most guarded certificate which signs all others. So if everyone trusts your root certificate, then by the chain of trust, they trust everything that was signed by that certificate. If they have it in the list of trusted root certificate authorities. So in this case, we will make it self-signed certificate without the certificate authority. In your scenario, you can use your certificate authority, you can use self-signed certificate, you can use third-party certificate authority like VeriSign and so on. In our scenario, it's pretty much enough. Usually it's enough to not have the certificate authority, but bear in mind that if you are creating the self-signed certificates, your root key, the one that you are creating once, and by which you sign all of your keys, it must be guarded. It must be kept in a very safe and secure location. If you are not familiar with certificate authorities, with certificates, with SSL, I would recommend to go through the course, to go through the training on it, at least like the CompTIA Security Plus. It's a very important topic. So, the MakeCert, it has two command line parameters. One is a question mark, and I mean, it has a lot of parameters, but we care about two of them. One of them is a question mark, and the second one is exclamation mark, which lists the extended options. As you can see, the question mark is the same as nothing, but exclamation mark returns quite a list. And we'll try to use some of them, because there might be situations when you will need it. In some cases, you will need less options. So we are trying to create the root certificate first, because we don't have it yet. The common name for that certificate, if you know about the common names, if you know about certificates, then perhaps you know that the common name for website, when we are creating the certificate for SSL website, it should be the domain name, the fully qualified domain name of that website. However, in this case, it's quite free-form. So we are writing PowerShell local certificate root. It's just a free-form string. The second parameter that we are using is A, which is the algorithm. You can see it in the list of extended options. And here it is. And the signature algorithm is either MD5 or SHA1, and default is MD5. And the reason why we are using SHA1 here, what is the difference? MD5 and SHA1 is a hashing algorithm. So the reason of signature is hashing. Hashing means that we are creating some binary garbage which is unique to the content of your file. If anything in your file is changing, you're changing 1 byte or 1 bit, that signature becomes invalid. Because when during the execution of in start of execution of your script, the PowerShell tries to recalculate that hash of your script, you change something, it's different. So signature is invalid and PowerShell will not execute your file. In this case, it's quite old makecert utility. Old means that current makecert that you will download should support more algorithms. So MD5 is the fastest one, but it's also the it was hacked. So the chances that your algorithm will become the target of attack, meaning that someone will hack the signature of your the MD5 signature of your script, well, they are minimal. It's perhaps in the end of the list of hundreds opportunities to hack into your network, hack into your environment. So I wouldn't bother about it. However, the main reason in having that choice in MD5 and SHA-1, most likely the policies that your company may have. For example, some system administrators set the FIPS compliance in policies, and according to FIPS, the MD5 is insecure, but SHA-1 is secure. Frankly, they both are hacked. The MD5 and SHA-1 are hacked. So it is possible that hackers could create the content that would fit your signature. But chances to have that attack are so minimal that I would stick to the default, unless you have the settings to be compliant with other algorithms. So if you have that requirement to be compliant with, say, SHA 256 algorithm, then use it, of course. Otherwise, stick to default and you'll be fine. The speed of algorithms, yeah, the MD5 is faster, but still, they all are fast. On current computer systems, the speed difference is known. You will not notice it. So, in this particular case, there's only MD5 and SHA-1. The current makecert also supports heavier versions of SHA, like SHA 256 and 512. So, as more bits, as safer it is, and as slower it is. It's not that you should take it into consideration, really, but take a look at your security policy in your company, in your network, in your environment. If you have FIPS compliance, then MD5, the default one, is not for you. Otherwise, you're fine. So the next one will be EKU, or comma-separated enhanced key usage. It's the biggest parameter here. You should Google for it. I definitely don't want to explain all the numbers here. Oops. You can use these ones or Google for them. Definitely, it's better to understand all of them. So basically, it's a key usage. How can you use this key? R means the self-signed certificate. It means that it will not be signed by any other key. It will be the root authority. you will have to explicitly set the trust for that key in the target system. SV means we are creating the private key file. If it's not present, and we are giving the name for that private key file, which will be the root.pvk. Again, you can name it as you want, as your company name, as you wish. This SIR file will be the public file, the public key file, the certificate itself. And SS is the subject certificate store name that stores the output certificate. What is the store name and store location? If you don't know, if you're not aware, please go through the training course. The store location is either user or machine, and we are storing it in local machine. And when we are creating that certificate, it asks us for a password. So if we set a password, it will be more secure, and we will be asked for that password during each use of that certificate. So for example, when we will create the certificates to sign new certificates that we will use to sign new PowerShell scripts, we will be asked to provide this password. So in this case, we are not using the password, we just press OK, and that's fine for PowerShell. However, as you can see, it's secured by default. It will ask you whether you are sure that you don't want security. So as you can see, two files were created, the root.sir and root.pvk. One of them contains the public key and one of them creates the private key. Especially make sure you don't share the private key, because then your root certificate will be compromised and everyone would be able to create scripts that would sign any code on your name. So now we are going to create the second certificate with which we will sign the PowerShell scripts. Again, the common name, which will be the PowerShell user, the user who will sign that PowerShell scripts. Again, the SHA1. The wonderful parameter. But in this case, we are signing this certificate with the private key that we have, with the root certificate. So if, for example, you have a company with many developers who will create the scripts, and maybe with many divisions, you can create a certificate for each one of them and sign each of this certificate with the root certificate. And then your clients will have to trust the root certificate, put it to their trusted root authority list, and then all of your developers will be able to ship their PowerShell scripts to the customers. So now is the command for signing that PowerShell script. You can write it down. It's set authenticate signature and the name of the file, and then the command which gets the certificate from current user my store. Because as you can see, during the creation of that certificate, we have set where we want to store it. So and then, as you can see, it's array, and we take the first key. It's the only one key. Okay, done. So now that file, that script is signed, and we can run it. So when we're trying to run it, we get the message, do you want to run software from this untrusted publisher? We didn't set the trust to that certificate. We just generated two certificates. So the question that you will have on first invocation of that signed script will be whether you want to never run from that publisher, scripts from the publisher, or do not run this one, or run once but do not trust the publisher, or always run, which means you will trust that publisher like forever, or help in case you don't know. So you just have to type one symbol as the reply. So we always want to trust this certificate. So all other scripts signed by that vendor will be run. Set execution policy. As remote signed will allow running all scripts. Alright, enough with that. Now let's talk a little bit about the authentication. And to illustrate that, we are going to run, we are going to read the event viewer on the other machine. And just to prepare to that test, we are going to create the rule that would allow us to connect to that machine through the firewall. So we're going to computer configuration, policies, administrative templates, network connections, Windows firewall. Since we are in domain, it's in domain profile, and then we are going to change one thing, which is, where is it? Allow inbound remote administration exception. So we are going to use remote administration through VMI, and we can do it manually, to create the firewall rule, but we can do it also through group policy, and we'll do it right now. And we will trust desk connections from local subnet, so from other computers in this local area network, actually from the same subnet. Good. So now we are on that Windows XP machine. The problem with cursor. Okay, we are running should run the GP update to update the group policy. Done. So we have that firewall rule here. Okay, we don't need this machine anymore. And now we are going from our Windows Server machine to read the event log. So we are using the getVMI object, which will connect to Windows Management Instrumentation on that computer. MTLCL1 is the name of the computer. We are going to connect to NT-log event, which is the event logger, and we will use the credentials from the dialog. And we are not going to connect to security, as it might be empty. We will connect to system. So we are going to save it as PS1 file to run it later. Okay, now let's take a look again at the script. Basically all the commands here are the syntax of getVMI object. So you set the computer name, but since you are system administrator, then most likely you will use that get_vmi object to connect to remote registry, event logger, whatever. So for example, you might have the scripts that will run time after time and see whether problems were logged to event logger, or perhaps you need to change the registry automatically, and so on. So the important thing here in this script is that getCredential function in the third line. So you can specify the credentials, and in this case we want these credentials to be asked for. So the script will ask us for credentials. So what credentials do you want to use? And let's see how it looks like. Here's our script, and we are running it. Okay, so we need to provide the credentials. As you can see, the caption is Windows PowerShell credential request. So we are trying to authenticate as the administrator, local administrator of that machine, providing the login name and password. So they will be submitted in secure form. And we get the list. We get something. However, let's try to do it again and specify the credentials which do not have access to that event log. Let's use the restricted account of the ordinary user of that machine, which would be the student. And we get the error. So, if you are using that getCredential, you will be able to ask for credentials without saving them in your script. And, well, that's quite good. If you will get help for getCredential, you will see other options that are supported by PowerShell. But at least it's quite secure, and if you remember the VB script, if you remember the Windows scripting host, then it's definitely a sort of achievement. Well, and this is like it. Next time we're going to talk about the workflow of the script. And thank you for watching, and have a good time.